Hello, Afton. How is everybody today? So last time we talked about algebraic reasoning, we just kind of stuck with this idea of given this equation, we were learning a format. That's the important thing of what we were doing. Well, now we're going to be building on that. We're going to be doing some combined reasoning. So we're going to be adding in some of these geometry ideas for what we've done. So again, these problems won't look new in terms of they're problems that I've asked you to do before. So that's not anything new. The new thing is going to be, again, writing those reasons for why that is the case. So right here, I told you that angle A and angle B are supplementary, and angle A equals 100 degrees, and I want you to find angle B. So again, this isn't anything that we haven't done. We've talked about supplementary. If you've forgotten what supplementary means, you should probably pause this and go look up that word because it's a very important word. So do not forget the word supplementary. Learn it now, keep it forever. So, and then I also told you some angle measurements. So we need to start this off. So when we start this off, we're going to go ahead and we're just going to write those givens. There were two things that we were given. We were given that angle A and angle B are supplementary, which I'm going to abbreviate here just for the sake of space, and then also that measure of angle A equals 100 degrees. So right there, just next to those, and if we want to go ahead and just say 1 and 2, just so that way we're keeping these things in line here. So that was given, number 1 was given, and number 2 was given. So pretty simple, pretty straightforward with that regard. So now where can we go from here? Because there's no equations or anything. Well, we can think about what some of these things mean. So we can think about, well, what does supplementary mean? Well, supplementary means that those angles add up to be 180. So then we can go ahead and we can say that. That's what it means. That's the definition. So our third line can simply be the measure of angle A plus the measure of angle B equals 180 degrees. And the reason we can say that is because, as I said, that's what it means to be supplementary. Anytime you're saying that, well, that's what it means. Then go, okay, well, again, the word for means is definition. That's the definition of supplementary. So that's the nice thing, is that we can use those definitions. Those definitions weren't just things that I told you to memorize for no good reason or learn for no good reason. We can use those definitions. So again, maybe you want to make a running list of some of these things that we're seeing in these right here, and then just have a sheet and say, okay, definition of supplementary, and then kind of write down, oh, well, that means they add up to be 180. So that way in the future, you can just refer back to that. That's a good strategy to help you with these, is just kind of have that list of some of the reasons that we've covered so far. And I would include those algebraic reasons. Now, a lot of times you don't need to write down examples of that, but again, maybe some of these other things, not a bad idea. Okay, so now, cool. Now we at least have an equation. So awesome. Now we have an equation. More importantly, we have an equation with the measure of angle B. So what can we do next? Where can we go from there? Well, we were also told what the measure of angle A was. So since I know what the measure of angle A is, I can just go ahead and I can make that statement there, and I can replace that angle A and say 100 plus the measure of angle B equals 180. Pretty simple, pretty straightforward. Cool. Now, what lets me just plug in something like that? That would be the substitution property. Remember, we abbreviate substitution, S-U-B-S, not to be confused with the next thing we're about to write, because now, if I just gave you this and I said, hey, let's get that measure of angle B by itself, how can I get rid of that 100? Well, I can just subtract that 100 away and say for line 5, the measure of angle B equals 80. And I just subtracted 100 from both sides. So then my reason right here is the subtraction property of equality. Which when you're writing, I think I did that last time, abbreviate equality, EQ. That's it. So now again, we're just taking the ideas that we already had. We're taking these ideas that we had with algebra and we're combining them with the ideas of geometry. So again, the math we're doing is not new. The format is the new thing for us here. So let's take a look at another problem here. Let's take a look at something a little bit more concrete here. So I've given you a bunch of measures. I told you to measure these guys here, and we want to find x. Now, just because we're formatting this new, just because we're doing something in a new context, doesn't change my recommendation. I would still say, take these things right here and write them in the picture. That's going to help you quite a bit. So if I go ahead and I say, okay, the measure of angle AQB is 4x plus 8. So then AQB is this guy right here. So write in there 4x plus 8. That's going to be a helpful thing, especially when we're trying to figure out how to set these things up. And then right here, the measure of angle BQC is that 2x minus 2. And then the measure of angle AQC, this big angle right there, is 48. Now, anytime we're doing any type of reasoning, always start off with those givens. There were 3 of them, so we want to write them. The measure of angle AQB equals 4x plus 8. The measure of angle BQC equals 2x minus 2. The measure of angle AQC equals 48 degrees. And again, for all those, we can just write given, given, and given. And I'm going to write those 1, 2s, and 3s there. Just because we might start running out of a little bit of room here as we're writing. Now, this next step is probably the toughest. This next step is probably the toughest here, because a lot of you guys probably looking at that picture over there, you're probably going, well, Mr. Keith, right away, we know that we can say 4x plus 8 plus 2x minus 2 equals 48. And I agree that will be an eventual line that we have in here. I agree with that 100%. The problem becomes, well, what lets me say that? What lets me build onto that fact that this is a thing? And what lets me build onto that fact is because we know, we've previously discussed that I know that, now instead of saying M, I'm going to use this symbol. I probably should use that from the beginning, but anyway. So I know that the measure of angle AQB plus the measure of angle BQC equals the measure of angle AQC. Sorry, I looked at the wrong thing. I know that this little angle plus this little angle equals that whole thing there. Why do I know that? Well, that's what the angle addition postulate tells me. It tells me that, hey, if I take this little angle and this little angle that make up this big angle, I can add them together to equal that. So that's what really my fourth line needs to be, is I need to say that that angle plus this angle equals the big angle. By angle addition. Now I don't necessarily need to see that word postulate. I don't care about that. If you say angle addition, I'm okay with that. And now for 5, all I did was I said, well, I plugged this guy in, I plugged this guy in, I plugged this guy in. And since I plugged in all of those things there, well, that's just substitution. So for 5, I can just say the substitution property. And that's it. Anytime you plug something in, anytime you replace something that was written with something else, usually algebra, usually some algebra expressions, that's just substitution. Easiest thing to write there. And then we can carry on. Hey, I got some like terms I can combine, so I can say 6x plus 6 equals 48. Not 84. That was a dyslexic moment. I apologize. So line 6 here. That was just, again, combine like terms or simplify. I'm just going to write simplify in this case, just because I don't really have room to write combine like terms. Now I just do a little bit of algebra. 7. So I'm subtracting 6 from both sides. 6x equals 42. Then for line 8, I can divide by 6. I know x equals 7. So again, I got to this line. I got to line 7 by the subtraction property of equality. Probably should have tried to space this a little better. And then I got to line 8 by dividing, so that is the division property of equality. We're justifying. As I said, a lot of times students look at this and go like, oh my God, that's a lot to write. And it seems like that in the beginning, but that's what you need to do. I mean, the example I gave last time is I can tell you pollution's bad. I can tell you pollution's bad. You can go, okay. Like you've heard it a million times. But unless you give me concrete reasons, unless you give me like, this is why it's bad, this and this and this and this and this, and this is why we need to try to prevent it. Unless you give all those details, you're not making a compelling case. All right? Right here, I mean, just again, sorry, I'm a sports guy, I make that. I can argue that, I can justify that the 1999 Rams to the 2002 Rams were the greatest football team in the history of the NFL. I could make that argument. I could go ahead and I could cite reasons why. I could say, oh, well, we had 4 MVPs. Like we had the MVP of the league every single year. I was like, we put up more in that time frame than anyone else. Like I can sit here and I can cite reason after reason after reason for why that was the case. That they should be 2-time Super Bowl champions if it wasn't for those cheating Patriots. I could go ahead and I could go on and on and on for why they were the greatest team. But if I just told you that they were the greatest, you'd be like, oh, okay, and you just move on. You wouldn't even really consider what was doing. That's what we're doing. We're making a case. We're building our argument to get to this point. So, what I'm going to do is I want you guys to try this on your own. Okay, see if you can come up with all the statements and then maybe come up with all the reasons. Okay, go ahead and try that. Pause. All right, hopefully you're back now. So now what I'm going to do is I'm going to write down all of the statements. I'm going to write down the statements. Now, if yours are in a slightly different order, that's okay. Like your givens, the order of the givens doesn't matter. If you for some reason wrote RT first, that's fine. That doesn't matter in the grand scheme of writing these things. So your statements should be RS equals 3x minus 2, ST equals 2x plus 7, 3 RT equals 45. Line 4 should be RS plus ST equals RT. Line 5 should be 3x minus 2 plus 2x plus 7 equals 45. Line 6 should be 5x plus 5 equals 45. Line 7, 5x equals 40. Line 8, x equals 8. So with that, now, what I want you guys to do is, again, compare, see if you did that right. And then now, if you did mess up, go back, look at your reasons. See if you came up with the proper reasons for all of these things. So go ahead and pause. All right, now that you're back, let's go ahead. So the first few are easy. Given easiest points you can make. If I gave you all those, I can tell you this is probably a 16-point question on the test. You just got 6 out of 16. Easiest points you can get there. Whitewashing. Sorry for the hand. There we go. So now, what lets me say that this piece here plus this piece there equals the whole thing? Well, that, ladies and gentlemen, is segment addition. Again, anytime I add two little pieces together to equal the big thing, that's just segment addition. And then for line 5, that's just the substitution property. I just replaced the RS, ST, and RT with what we already said they were. Then line 6, again, combine like terms or simplify. Either one is fine with me. Line 7, I went ahead and I subtracted 5 from both sides, so that is simply the subtraction property of equality. And then line 8 there, I divided both sides by 5 to get there, so that is simply the division property of equality. There you have it. So again, taking these ideas, taking these problems that we've already discussed, taking these things that we're already aware of, and kind of bringing them together, bringing these ideas into the same realm. So now there are a few definitions. There are a few things that I want to talk about, a few properties moving forward that we just kind of need to be able to identify, and that is the reflexive property of equality. The symmetric property of equality. And transitive property of equality. Sorry that I didn't have these typed down, typed up. I thought I did, and then all of a sudden I realized, like, oh, I think I forgot. So, what the reflexive property states is if A exists, that one needs X. if A exists, then A equals A. We can always say something is equal to itself. I am as tall as me. That's the easiest way to kind of think about it. Now, at the beginning, you might be like, oh, that seems kind of like a weird thing to say. We will need the reflexive property more later on. Right now, it's just kind of a thing that we need to make sure we can identify. Anytime we say something is equal to itself, that's just the reflexive property. 5 is the same as 5. The symmetric property states if A equals B, then B equals A. If I'm as tall as Mr. Snyder, Mr. Snyder is as tall as me. Those two things go hand in hand. Now, here's what I try to tell students about the symmetric property. This is the greatest property that you use that you never recognize that you use. Here's the example. So if we have 5 equals 2x minus 3. Okay, I'm talking about solving. Just forget the reasoning and all that for 2 seconds. If we add 3 to both sides, we get 8 equals 2x. Divide by 2, then what do we get? If you said x equals 4, no. What we should get is 4 equals x. X is on the right side. This is what we should really write. We don't write that. When we get to this point, we all write x equals 4. We do that instinctively, and that's fine. Again, this is not wrong to write x equals 4. That's the first thing I want to say. But this is not what I should get going from this line to this line. What I should get is 4 equals x. But because of the symmetric property, we just say x equals 4. And that's perfectly fine. So as I always try to tell students, the symmetric property is the greatest property that you use that you don't even realize that you're using it. It just, like, you just use it so instinctively that you just know it so well that it doesn't even cross your mind that you're using it. But again, of these 3, this is probably the one that you honestly use the most. So for the transitive property, that states if A equals B and B equals C, then A equals C. So again, I use height because I think it's just an easy thing. So if I'm as tall as Mr. Snyder, and Mr. Snyder is as tall as Mr. Polakonis, well, that means that I'm as tall as Mr. Polakonis. That's what the transitive property says. If A equals B and B equals C, well, then I know that this guy right here, this A, has to equal that C. That's all the transitive property states. Now, of these 3 in the beginning, we use the transitive property quite a bit. We use that quite a bit. Like I said, the symmetric property, we use it, but it's such a fleeting glance that we just don't even recognize we use it. But we will use this one quite a bit, transitive property. We'll see that moving forward. The reflexive property, like I said, it's going to take a back seat, but then all of a sudden it's going to come roaring back in a few chapters, and you're going to be like, oh my God, we're using this all the time. So, if something can satisfy all 3 of these, reflexive, symmetric, and transitive, then we call that an equivalence relationship. We know that these 2 things, we can divide things up. In equals, we know that we can use equals to divide things up. Again, this, in the grand scheme of mathematics, super, super important. I was like, for what we're doing, yeah, we're going to use just a small percentage of it. But I do try to tell students that in the grand scheme, this is super duper important. I agree with that property. So that's all I have today. You have an assignment, so make sure that you are working on that assignment. That's all I got. So until next time, I will bid you adieu. Stay safe out there, Afton.